Welcome to Brain Vision.
For this question, it says two long straight wires each carry current I out of the page toward the viewer. So I have the two wires here, the top wire and the bottom wire, and both are carrying that current I out of the page, which is why they're represented by a dot. So an X means into the page, a dot means out of the page. So this is similar to figure 35, and it wants us to draw the directions of B at each point 1 through 6 in the plane of the page and state if the field is 0 at any of the points. Okay, so let's just go through them one by one. We're going to use the right-hand rule, and we can get the direction of the magnetic field at any point due to the two long straight wires. So the magnetic field due to current carrying wires, the top wire, that's directed out of the page at point 1 is towards the right. So using the magnetic field, you point your thumb in the direction of the current, and then you curl it, and the direction of the curl is the direction of the magnetic field. So at point 1, that magnetic field is going to be due to the right, and it's very close to that first I value. And so since it's closer to the top one than the bottom one, that top one's going to take over. And so we'll do all this in red. It's going to be, oh, that's a little too large. Let's use a smaller cursor there, and we'll retry this. Okay, so go back to our red. At point 1, it's going to be in this direction. Okay. Next, we're going to do point 2. So at point 2, it's in the middle of the two current wires. The magnitude of the magnetic field due to the top and the bottom wire are the exact same, but if you, again, follow the right-hand rule, they're going to be in opposite directions. So therefore, the net magnetic field is going to be 0. So at point 2, we can say B equals 0. Well, then at point 3, using the same reasoning at point 1, we point our finger or our thumb in the direction of the current, which is towards us, and we curl our fingers, and that's going to show that 3 is going to be directly to the left. Okay, and then let's move on now to point 4. So using the right-hand rule in the magnetic field at point 4, due to the upper wire, it is in the upwards direction. So if you point your thumb towards you, curl your fingers, you'll know due to the top wire, it's in the upward direction. But at point 4, due to the bottom wire, it is perpendicular to the radial line between the bottom wire and point 4. So therefore, the resultant magnetic field due to both wires at point 4 is going to be a combination of the upward motion of the first one and the motion to the left from the bottom wire. So you add those two components. Of course, the top one's a little stronger, so it's going to be at an angle kind of up and to the left, like that. All right. Well, how about now 5? So the magnetic field at point 5, due to the upper wire and bottom wire, are going to both produce a magnetic field in the upward direction. So if you point your finger towards you and you curl it, up is the direction from the first wire, right? And then from the second wire, you point it towards you, and you begin to curl, and it's also going to go upwards. So at point 5, the directionality is up. And then finally at point 6, it's going to be the exact same logic and reasoning as point 4, but now, because the bottom wire is closer, it's not midway in between the two, what we're going to end up with is a motion from that top wire. It's slightly going to move it into the right, but the bottom wire is pushing it up. So a linear combination of both right and up gives us something like that. So these are all the magnetic field lines that we needed to draw for this situation.